Hello guys, how are you doing? Nice to meet you today again. And today I want you to talk about cross product of the vectors. Uh, Cross product we usually define for 3D space, and so it means that vectors have only three components. And definition for cross products is the following one. So you have two vectors. A vector has components ax, ay, and az. So it has three components. And b vector has components bx, by, and bz. So cross product of two vectors a, b, a cross product b, so a bar, b bar here. It is the determinant of the matrix, which consists of the very first line, consists of the unit orthogonal vectors in Cartesian coordinate system I, j, k here. Second row consists of components of the vector a, and the last one row consists of the elements of the vector b. So the first one row consists of vectors, and the second and third of numbers. If you expand this formula, it gives. You can use the regular rules for determinant, how calculate determinants for 3 by 3 matrices. It gives I vector times ay, az, determinant or minors I minor, bz minus j. I remind you that we have to switch the sign of the terms here. Minor 1, 2. So I have here the part of the submatrix ax, az, bx, bz, and plus k times ax, ay, bx, by. And if I try to expand the 2 by 2 matrices, here I have I times ay, bz minus az, by minus g ax, bz minus az, bx plus k times ax, by minus ay, bx. This is the formula for vector product, the first formula here. But if you can't calculate determinants, you have to remind to cement here the only one in your mind, the only one formula here. This one. And if you need to calculate something, you can expand the formula according to the standard rules for determinant calculation. But there is also one formula, another one formula, so you can use for vector product a dot product B equal magnitudes of the vectors A and B times sine of alpha times n vector. N vector, it is very special vector. The magnitude of n vector equal 1, so that is a unit vector. And this vector is perpendicular to the vector A and simultaneously perpendicular to the vector B. And you can define the direction according to the right-hand rule. Direction over the n, direction of n, you can define on the basis of the right hand rule. What does it mean? For example, you have a vector A. Also, I want to use the other one, pencil here. Right hand rule. How does it work? Right hand rule. Okay, right hand rule. How does it work? For example, you have vector A, this black pen, and this vector B. So you have to take your black this pen so that your fingers thumb looks along vector of this black pen A vector, and your fingers you have to bend towards vector B. And these fingers show you the direction of the vector n. Okay, clear. I don't think is it clear or not, but you can train yourself if you want at home. Anyway, vector n, direction of the vector n, defined on the basis of the right hand rule. According to the definition of the cross product, you can notice that here A cross product B is not equal B cross product A. So here you have your home assignment. Try to explain why. Okay. Next, our work for today is about some examples. The definition has a hint at the works which can be facilitated with the cross product. So if you have to find out, for example, something perpendicular to some objects, for example, a straight line perpendicular to the plane, or you have two vectors and you want to find out the third one which is perpendicular to both of them, it's the best way here is to use the cross product or vector product. Some people say this operation, especially in Russian, vector product. So that kind of work you can face in physics and some courses about electricity. You have to find out something perpendicular to the given something. And for example, in physics you can phrase this work if it is about some moments or forces. I don't know real terms about physics here. So anyway, if you have a work to find out something perpendicular to some object, the way to find this perpendicular thing is a cross product. So this cross product always gives you something perpendicular to other one thing. This is the usage. This concept define the usage of the cross product thing. Okay, and about cross product as a definition, you can notice that otherwise than dot product, here we have for identifying multiplication of the product the cross sign, and since that it is a cross product. And Russian tradition, as I said before, we use the term vector product because the result of this product is a vector. So here you can notice the difference, some differences between dot product and cross product. Dot product gives a scalar number, vector. A cross product gives you a vector. And firstly, we can calculate some examples. Okay. For example, if you have a equal, I don't know, 1, 2, 3, for example, and vector b is, for example, 0, -2, 1, and we have to calculate a cross product b is something unknown. So we can use the direct formula a cross b, cross product b, a bar, cross product b bar, gives determinant of the matrices a, I, j, k, 1, 2, 3. I, j, k, they are vectors, so I have to put here bars. O, -2, 1. You had this theory before, but I want to remind you here about ijk vectors. So if you consider, I use here a red ink, the Cartesian rectangular coordinate system x, y, z axis. So vector I is a vector which is along axis x vector, and it has components x component y and zeros y and z coordinates. So j vector looks on axis y and it has components 0 x component, y component, and 0 z component. And k vector, it is kind of a z vector, so it has components 0, 0, y. All these vectors, they are unit vectors because they have magnitude equal 1, and these three vectors, they are perpendicular to each other. So k vector is perpendicular to the vector I, j vector is perpendicular to the vector as well as j here. Okay. So the result of the cross product is kind of a decomposition, gives a decomposition of the vector on the basis of the I, j, k vectors. All these things we had in our previous lecture, before previous lecture. So if we use here the direct rule of the determinants calculation, we have I times 2, 3, -2, 1 minus j times 1, 3, 0, 1 plus k. In our Russian tradition, we put plus here and plus here. So when we are moved to the other line, we run more again, put plus here. Okay, 1, 2. We really like to put some extra sign and extra brackets. Foreign students, they hate extra vectors, extra brackets, extra parentheses. Sometimes it's good, but sometimes you can mess the order of operation if you mess the brackets, and that's why we kind of back up our calculation using these extra signs. And we have I times using cross product here, 2 times 1 minus 3 times minus 2, extra bracket here, extra parentheses, minus j 1 times 1 minus 3 times 0. Don't forget about bar here because j is a vector, plus k times 1 times minus 2 minus 2 times 0. So we have here 2 plus 6 minus j times 1 plus k times minus 2. No, because 2 times 0 gives 0. And we have 8 times, I forget to put here bars, times I minus 1 times j minus 2 times k. So this is the new vector. I denote it's like C, vector C, like a cross product, and it has components 8 minus 1 minus 2. Okay. How can we check this, that this vector is a perpendicular to both of the given two? Let's check it. Check if C is perpendicular to the vector A and vector B or not. It's very easy to do here. Even I use here new ink, if you don't mind. I tried to make it for the vector A. I have to calculate a dot product. C dot product B, no, A for example, and I have 8 times 1 plus minus 1 times 2 plus minus 2 times 3, and we have 8 minus 2 minus 6, it is 0. So it means that C is a perpendicular to the vector A. So if you want, you can check the same thing about vector B. So if you calculate the dot product C dot product B, you will have 0. So it will be it will mean that vector C is a perpendicular to the vector B. We have two definitions for the vectors A and B. A and B vector. So you have A cross product B, the other one definition, magnitude A, magnitude B, sine alpha here alpha is an angle between two vectors, times n. And I said before that n vector is a unit vector, so its magnitude equal 1, and this vector is a perpendicular to vector a and b. And some people say that vector n is a normal vector. Is a normal vector. So what does it mean? Sometimes you can face a problem that you have to calculate a normal to the given surface or to the given plane. So it means that you have to find out the how to say it, the unit, the vector which is unit and which is perpendicular to both of them. So normal vector and is equivalent or the synonym for words vector which is perpendicular to something with length 1. And to give you here, and I want to give here an example. So here we have example here. You have vector A equal, for example, I don't know, 1, 2, 3, for example, and vector B equal, I don't want to calculate too much, that's why it will be 0, 0, 0, 3, and you have to find out vector n which is perpendicular to both of the given vectors. It's very easy to do. Here, the first one step, you can find out vector C, which is result of the cross product of the vectors A and B. I, J, K vectors, and here you have 1, 2, 3, and 0, 0, 3 components. It's very easy to calculate, so it is I times 1, 2, 2, 3, 2, 3, 0, 3. Minus J 1, 2, 1, 3, 0, 3, and plus K 1, 2, 0, 0, and it gives you I times 6, no, 3 times 0, 0, minus J times 3, J bar, don't forget about bar. No, K has a factor 0 here, so I drop it. So vector C has the following components: 6 minus 3, and since that we have the 0 third term here, it means that the z components of this vector is 0. Okay. Next, our step to normalize this vector to make it unit, to calculate the unit vector along vector C. So I denote here n as a vector C divided by the magnitude of this vector, and it gives the following thing here. It's just the 1 over square root 6 squared plus minus 3 squared times components of the vector C. And finally we have the result 1 over 6 square root of the 36 plus 9. I put here in the denominator 6 minus 3 0, and it gives vector 6 over square root over the 45 minus 3 45 0. So this is the final result here. This vector is a perpendicular to the vectors A and B, and it has the magnitude 1. By the way, you have here a home assignment. Check if vector magnitude of the vector n equal 1. Okay. And we can say that this vector is a normal vector to A and B vectors. Okay, see you later.